Good morning, everyone. In this video, I'll be talking about Hardamite factorization method or theory. That is a complex analysis. I'm going to break it down for you to understand how you can use it to solve some examples, calculate the order of Hardamite factorization theory. Please make sure you share this video, like and send to your friends, share it to your friends, those who are finding it difficult. Thank you and God bless you. It's okay. Complex analysis. Complex analysis. Complex analysis. Then we are going to look at Hardamite Factorization Theorem. Amen. Hardamite Factorization Theorem. Okay. I'm going to state the theorem. Then we are going to look at some calculations, how to find the order. Amen. Okay. It states that if f of z is entire and has finite order, and have zeros, and points. The points are talking about z1, z2, z3, and f of z not equals to 0. Then this implies that our f of z is equals to exponential phi of z times p of z, where p of z is the canonical product, I think yes, the canonical product form with zeros of f of z, amen, and our p of z is a polynomial of degree less than or equal to the other, this, amen, or you can write it this way, no problem. That is this is it. So this is the theorem of Hardamite factorization. So should in case you are asked to state this, this is what you are going to state. Then if we are to look for the order of Hardamite or a given function, this is the formula you are going to use if assuming, okay, that is m arrow, if assuming the function is assuming f of z is equals to exponential minus z, comma the function minus z is equals to, okay, let me write it better. Assuming you have been given the function f of z is equals to exponential z, sorry, exponential minus z. It means our m of arrow, comma, exponential minus z will be equals to limit, upper limit of arrow to infinity log times log of m arrow, comma, exponential minus infinity all over log arrow. So it means this is the order. Is the order. Take note. Amen. Okay. This is the order. So if you want to find the order of exponential minus z, this is the formula you are going to use. Are you following? So let's look at, let us use Hardamite factorization method to calculate one problem, one or two problems. Amen. Okay. Let's look at this problem. It's simple as ABC. Any question? No question? Okay. So I can clean everything. Yeah. Okay. Let's look at this problem. It's not difficult. Make sure you follow me, subscribe to my YouTube channel. Okay. Let's look at this problem. The problem says use example use the Hardamite factorization method or theory. Amen. Theory to factorize exponential minus z and deduce the factorization for sin z. Amen. It's simple as ABC. I'm going to break it down for you. Amen. Okay. So let's look at this idiot. Okay, now they said we should use the Hardamite factorization theory to factorize exponential minus z and deduce the factorization for sin z. It's simple as ABC. What we need to do first, let's write solution. Let's consider exponential minus z. Okay. In Taylor series, if we want to expand this in Taylor series, This is the same thing as 1 minus z plus z squared all over 2 factorial minus z raised to power 3 all over 3 factorial plus z raised to power 4 all over 4 factorial minus z raised to power 5 all over 5 factorial plus z raised to power 6 all over 6 factorial minus true or false. Okay? So this is a Taylor series form. So what we need to do is, if we know that our mode z is less than r1, it means we are going to take the modulus of this series. So definitely this will now be mode exponential minus z will now be less than modulus of 1 minus z plus z squared all over 2 factorial minus z raised to power 3 all over 3 factorial plus z raised to power 4 all over 4 factorial minus z raised to power 5 all over 5 factorial plus z raised to power 6 all over 6 factorial minus the modulus. Okay, so this is this will now be equals to 1. Since we want to take the mode of z, this negative sign will now be plus mode z plus mode of z raised to power 2 all over 2 factorial. The same thing applicable plus z raised to the powers of 3. You know, because of we are taking the mode of this, so this will now be positive all over 3 factorial plus mode of z raised to power 4 all over 4 factorial. The same thing applicable here. This minus will now turn to plus z raised to power 5 all over 5 factorial plus mode z raised to power 6 all over 6 factorial minus Amen? Okay? So now what we are going to do is, we know that our mode z is less than equals to arrow. So anywhere you see mode z, you substitute in arrow, but mind you, the mode having what? Squares, true or false. So take note of that. So for this reason, we are going to write it this way. This will now be 1 plus arrow plus mode z is arrow here will be square, arrow square all over 2 factorial plus the same thing applicable here. Please, are you following? Okay. Here would now be r raised to power 3 all over 3 factorial, then plus the same thing applicable r raised to power 4 all over 4 factorial. You know that we know that our mode z is less than r. So plus r raised to power 5 all over 5 factorial plus r raised to power 6 all over 6 factorial minus Okay, do you agree with me? Okay, so if you agree with me, it implies that the whole of this will now be equals to exponential arrow. Amen? Okay, exponential arrow. Yeah, what is the problem? You want to solve mathematics? Don't mind my daughter, she wants to, whenever her father is solving mathematics, she wants to also solve. Okay, sorry, yeah? Sorry, okay? Don't worry, your time is coming. Yes. Okay, so let's come back to business. That is my daughter. She can disturb. It's okay. So let's come back to business. It implies that mode z we're going to give us, for this series, it will give us what? This exponential what? R. Okay? So, now we are able to factorize this using Taylor series. So now, at this point, the next thing to do is to look for the order. Amen? So how are we going to look for the order? It means we are going to, let's do it this way. Okay. The order will now be, no, I told you, the order will now be, means our n of arrow, comma, exponential minus z, will now be equals to upper limit. Upper limit, the reason why it is called upper limit is because of this. Upper limit arrow tends to infinity log times log n of r comma this exponential minus z, amen, all over log r, amen. So if you agree with me, we are going to solve these idiots together. So if you agree with me, it implies that this is equals to limit, upper limit r tends to infinity log we know that this is the same thing as n of r comma exponential z. Amen. Okay. So it implies that this is equals to this. Please take note. So exponential r all over log r. It's as simple as ABC. Is that clear? So if you agree with me, here we have two logs here. So we can write it this way, if I were you. Our limits, upper limits, r tends to infinity. Here will now be log, open a big bracket for this, log exponential r all over log r. You agree with me? So if you agree with me, it implies that this is r, this is r. Okay? Yeah, go back to the laws of logarithms, or this is the same thing as log. If log exponential r is going to give us what? 1 times r, two of us. So here will now be equals to upper limit r tends to infinity, then log exponential, that is, if we have log exponential, this is equals to 1. Two of us. So please take notes. That is what we are using. So here, since the exponential is r, exponential r, so times r times 1 is the same thing as r. So here will be r, amen. Please take notes. Here will be r, here will be r. So if you agree with me, all over log r. So this will going to give us what? 1. So the order of this, that is, this is the order, amen. The order of this function gives us what? 1. You agree with me? Now, you said you use the factorization for sine z. We are going to do the same thing here. We'll do the same thing here. But let's look at it together. Let us consider we've done exponential minus z. Then let's look at sine Z. Is that clear? Any question? I want to clean this. Any question? No question? Is okay. Okay. Let's consider sin Z. Okay, let's consider sin Z. We are still going to use Taylor series to factorize this. So if we are to use Taylor series, it means we are going to have Z minus Z raised to the power 3 all over 3 factorial plus Z raised to the power 5 all over 5 factorial minus Z raised to the power 7 all over 7 factorial plus Z raised to the power 9 all over 9 factorial. Then this implies minus Z raised to the power 11 all over 11 factorial. Then plus true or false. Okay? So this is how, if you want to expand sin Z in Taylor series, this is what you are going to arrive at. Okay? So if you agree with me, let us always remember that our mod Z is less than R. So if we take the modulus of sin Z is less than mod of Z minus Z raised to the power 3 all over 3 factorial plus Z raised to the power 5 all over 5 factorial minus Z raised to the power 7 all over 7 factorial plus Z raised to the power 9 all over 9 factorial minus Z raised to the power 11 all over 11 factorial plus amen, then the modulus. So if you agree with me, this is equals to, if we take the mod of Z and take the mod of Z raised to the power 3, mind you, here will now be positive. So here we are going to have mod Z instead of minus here because of the modulus. Here will be plus mod Z raised to the power of 3 all over 3 factorial plus mod Z raised to the power of 5 all over 5 factorial plus the same thing applicable, mod Z raised to the power of 7 all over 7 factorial, then plus mod Z raised to the power of 9 all over 9 factorial, then plus the same thing, mod Z raised to the power 11 all over 11 factorial plus amen. As simple as ABC. I hope you are following. Okay? So if you agree with me, it means since mod Z is less than R, so anyway you see mod Z, you substitute in R. So this is less than equals to R plus R square, R raised to the power 3 all over 3 factorial plus R raised to the power 5 all over 5 factorial plus R raised to the power 7 all over 7 factorial plus R raised to the power 9 all over 9 factorial and R raised to the power 11 all over 11 factorial plus amen. Do you agree with me? I hope you are following. You can see what I am saying now. Then, note that this will now give us a parabolic function of sine R. Take notes. So this series is the same thing as sine R is this. So please take note. Are you following? So if you agree with me, it implies that our mod sine Z is equals to sine R. Then go back to your hyperbolic functions where shine arrow, shine x. Amen? Okay, can I clean this part? Go back to your hyperbolic function where we know, or you know that shine arrow is the same thing as exponential arrow minus exponential minus arrow all over 2. So this is the same thing as this. So please take note. Are you following? So this implies that this is the same thing as exponential arrow minus exponential minus arrow all over 2. Amen? Okay? So now we are going to consider the order of sine z. Let us consider the order of sine z. The order of sine z. Okay? Order of sine z. Let me just write it this way. Order of sine z. Sine, okay? Sine z. Amen? Okay? So if you agree with me, the order of sine z, how to obtain the order of sine z is, let's recall the order of Hardamite factorization method. The order is always of this form. M of arrow, since we are talking about sine z. Sine z is now equals to upper limit arrow tends to infinity log times log again open bracket m open bracket arrow comma sine z all over log arrow. Take note. So we are going to make use of this formula to obtain the order of sine z. Okay? So now you know very well. Do you understand? You know very well that our sine z is exponential arrow minus exponential minus arrow all over 2. True or false? So it means the order, that is m of arrow minus sine z. Okay? Let's write it this way. Okay. So note that our m of r comma sine z is equals to exponential arrow minus exponential minus arrow all over 2. True or false? Okay? So if you agree with me, it implies that okay, can I clean this up? Let me clean this up so that we understand it better. It implies that our upper limit arrow tends to infinity log times log of this m arrow of sine x is what? Is this. So we are going to write this open bracket for it, exponential r minus exponential minus r all over 2 all over log r, the formula. Is that clear? So do you agree with me? Okay? So if you agree with me, this is the same thing as, please just follow me up, because at this point we are going to use our elementary algebra to do anything that we want to do here. So the upper limit of r tends to infinity log times log open bracket, let us open a bigger bracket. We know that this is, we can write this as this. We do not commit any crime. True or false? All over log R. True or false? Okay. Can I clean this? Okay. So if you agree with me, this implies that this is the same thing as log of upper limit R tends to infinity log times log open bracket. We know that this is the same thing as 1 R over 2 open a smaller bracket for each R minus exponential minus true or false R over log R. Amen. True or false? Do you agree with me? Huh? Okay. So if you agree with me, it's simple as ABC. If you agree with me, this implies that this is equals to, mind you, we have two log here, log, isn't it? So let us start with 1. We'll make use of this upper limit of R tends to infinity log open bracket. If you can see what I am saying, we can rewrite this out this way, log. True or false? Open bracket, this log has come inside there, exponential R minus exponential minus R, isn't it? Open bracket all over log R. Amen? Okay? So if you can see what I am saying, I'm just breaking down for you people to understand, most especially for manians that always find it difficult to understand and know. That is why I'm breaking it this way. Okay? So it means we are going to multiply out this bracket. So if you agree with me, our upper limits R tends to, it means our log open bracket 1 all over 2. Let's open this bracket. Here we're going to give us log exponential R minus log exponential minus R open bracket all over log R. Amen? Do you agree with me? Okay? So if you agree with me, here we are going to use our elementary algebra here. You know that if we have log exponential, this is the same thing as 1, true or false? But what if we have log exponential R? This will now be equals to 1 times R, which is equals to R. Then what if we have log of exponential minus R? This is the same thing as 1 times minus R, which is equals to what? Minus R. True or false? Do you agree with me? Okay. So if you agree with me, it means instead of this, we are going to write R. Then instead of this, we are going to write minus R. So this is equals to upper limit R tends to infinity. We have log all in bracket. Mind you, there is half here. Don't be in haste. Open bracket log exponential arrow will give us this arrow. What do you have here? Minus. But note that log exponential minus arrow is minus arrow minus arrow. Amen? Close the bracket. Then all over log arrow, isn't it? So if you can see what I am saying, we can, let's write it. I'm breaking it down for you. Breaking it because of the sake of manias. So here will now be log of 1 all over 2. Then this one will now be arrow plus minus times minus will give you plus all over log arrow. Then this is equals to limit, upper limits, arrow tends to infinity. Amen. Then here will now be log open bracket 1 all over 2 arrow plus arrow will give us 2 arrow, amen, all over log arrow. Then this is equals to, if you can see what I am saying, look at it, look at the box very well. If you can see what I am saying, this and this will go, true or false. So the upper limit of arrow tends to infinity. Then we are going to have log of here will be arrow, isn't it? All over log arrow, amen. Then if you can see what I am saying, don't need a prophet to tell you, don't need a prophet. So here will now be upper limit of arrow tends to infinity, log arrow all over log arrow. Discover that this is equals to what? 1. This is the answer. So this implies that our sine z, the order of sine z is equals to 1. Then the order of exponential minus z2, it gives us 1. It means they are all the same thing, true or false? They are all the same thing. So this is how to use Hardamite factorization method to solve for calculate the order of sine z and exponential minus z. Please make sure you subscribe to my channel, my YouTube channel, and always follow me. And I have a website too. This is it, Remjock Maths. Go to this my website, Remjock Maths, RHEMJOCMATHS, Remjock Maths. Just type this on Google, you will see my website and also my YouTube channel. Make sure you share this video until you get to someone. I know that this solution is an example for somebody, is an assignment for someone to do. So please try and share this video. Don't be stingy and don't be greedy. Thank you and God bless you.